Okay, this is question one of the Prep for Control Test 3, actually, what it is, the third control test in the year. Here's the first question, a calculus one, where they asked to calculate the maximum volume of the cylinder. And the first two questions are kind of prep for it. They've given you the formulas, so you don't have to get the first two right to be able to do it. But here's how you do it. So there's the cylinder, and they say the first question is determine h in terms of r. Well, the sentence says the sum of the height and twice the radius is 20. You've got to be able to write h plus 2r equals 20. Now, to write it in terms of r, you just subtract 2r from both sides, and you get h equals 20 minus r. This is the height in terms of r. The reason you need that is because the volume of the cylinder is pi r squared h. You need to put everything on this right-hand side in terms of r, so you can take the derivative later on. Well, that's pretty easy because h is equal to 20 minus r. You just replace it with 20 minus r. Then you multiply it out, and you can show that the volume is actually 20 pi r squared minus 2 pi r cubed. Okay, the last question is it says calculate the maximum volume of the cylinder. And to get this is really some kind of function, but to get local maximums and minimums to answer these questions, all you have to do is take the derivative and let it equal 0, and you can find the maximum. So we do that. 2 times 20 is 40, and you bring it down 1, it's just 40 pi r. 3 times 2 is minus 6, and you bring it down 1, it's r squared. Now, the key thing is you let it equal 0, okay? And now, what I can do now is I can look for common factors in here. I see that 2 and pi go into both. So I divide everything by 2 pi. 2 divided by into 40 gives me just 20. Pi divided by pi, it cancels. And 6 pi divided by 2 pi is 3. Now you want to factor, you can see there's an r in both, so you factor it outside, and now you're kind of looking at your answer. You know that the solution to this is r is equal to 0, but that doesn't make much sense. You go 20 minus 3r must equal 0, and if you just solve that equation, and to make it work, to make this equal 0, r must be 20 over 3 centimeters. I'm okay to leave it like that. I guess it would be 6 2/3 centimeters, or 6.66 centimeters, but that's your answer for the radius that's going to maximize the volume. And that's question one of this little prep thing. Okay.